some angle relations. So there are certain properties of angles which we are going to discuss in this topic, right? Put the heading adjacent angles. Adjacent angles. So what are adjacent angles? When two angles are called adjacent angles, these are the properties of the two angles, right? Okay. So two angles are said to be adjacent if they are having the same vertex, they are having a common arm, and their non-common arm are on either side of the common arm. That means, so write down two angles are called adjacent angles if they have a common vertex.
Mama sent the doubts.
Okay. They have the same vertex. Secondly, they have a common arm, means their one arm is common, right? They have a common arm. And the third, their non-common arm. Their non-common arms are on either side of the common arm. Okay, means, for example, let's see what are adjacent angles. Suppose right, you can see there are two angles, right? Right, AOC and COB, right? Okay, this angle and this angle, right? Now in this given figure, angle AOC and angle BOC, right? They are adjacent. Why they are adjacent? They have a common vertex. Yes or no? Both are originating from the same vertex, that is O. Are you getting my point? See to the screen. See the figure, right? So both are originating. Both are having the common vertex, right? So this is the common vertex for both the angles, this and this angle, right? Okay. So this is the first condition, that they have the same vertex. And the second condition is that they have a common arm. So look at this arm, the middle one. This is the common arm. OC is the common arm, right? They have a common arm, that is OC. Are you getting that? Okay. So OC is the common arm. And the non-common arms. What are the non-common arms? OB and OA. These are the non-common arms of the two angles. They are on the either side of the OC. Means एक इधर है और एक इधर है, right? Means OC के either side पे हैं दोनों, right? एक उस side, एक इस side, right? Okay, so this is the third condition for the two angles to be adjacent. Are you getting that? Right? So OA, arm OA and OB are on either side of OC. Are you getting that? Okay,
Yes,
so
ma'am.
here, yeah,
Ma'am,
so AOC and BOC are said to be adjacent angles. Now, after adjacent angles, let's see what a linear pair of angles. Again, this is a pair of angles, but this time, this linear pair of angles are actually two adjacent angles, and they are said to be linear pair of angles if their non-common arms are two opposite rays. Right? Okay. So what is linear pair of angles? Linear pair of angles means there are two adjacent, these are two adjacent angles, right? And they are said to be linear pair of angles. Linear pair of angles if their non-common arms are two opposite rays. Means the two non-common arms are making a straight line, right? Okay, they are two opposite rays in the opposite directions. Are you getting that? Okay, let's see the example. Means, what does it mean? Suppose we have a we have adjacent pair of angle. Yes, look at there. Look at this. Are these adjacent angles? Yes or no? This is O, this is A, this is C, and this is B. Angle AOC and BOC are adjacent or not? Tell me that. They are adjacent? Yes or no? Saman and B. Are they adjacent angles?
Ma'am, what?
These pair of angles which I have drawn here, angle AOC and BOC, are they adjacent angles?
Yes, ma'am.
Yes, Sama, are they adjacent angles or not?
Yes, ma'am.
Yes, why they're adjacent? Because they have a common vertex. This is the common vertex. They have a common arm. Yes, they have a common arm. And non-common arms are on the either side of the common arm. Yes, that is also true. That means these angles, this pair of angle are actually adjacent angles, right? Now, when this adjacent pair of angle is said to be linear pair, right? They are said to be linear pair if their non-common arm, this one and this one, they are exactly opposite to each other and they're making a straight line. So you can see that their non-common arm, OB and OA, are exactly opposite to each other. Are you getting my point, Sama? Right? And they're making a straight line. Okay. In that case, these adjacent pair of angles are also called linear pair of angles. Is that clear? They are called linear pair of angles. Okay. And so you can see here angle AOC and angle BOC, right? These are two adjacent angles whose non-common arms OA and OB are two opposite rays. Are you getting that? They are exactly opposite to each other. Are two opposite rays. Right? So you can see that opposite rays means they are forming a straight line. Right? Means BOA is a line. Right? These two opposite rays make a straight line. So BOA is a straight line. So in this case, we say that angle AOC and angle BOC are linear pair of angles. What kind of angles they are? Linear pair of angles. Okay, are you getting this? That means what? Adjacent angles are said to be linear pair. Means जो linear pair of angle है, वो पहले adjacent angle है, right? They are actually adjacent angles, right? This is a special case of adjacent angle pair where the non-common arm are exactly opposite to each other, forming a straight line. Right? So such type of adjacent angle are also called linear pair of angles. Are you getting that? Okay. So adjacent ye bhi hai. If you are having this type of angle, this is also adjacent, right? This is also adjacent, right? But here you can say the opposite rays are not forming a straight line, but here they are forming the opposite straight line, and that's why these pair of adjacent angles are said to be linear pair of angles. Is that clear? Are you getting this? Now, there are certain theorems, or you can say results, on these angle relations. right? So write down theorem 1. Theorem 1. What if theorem 1 says? If a ray stands on a line then the sum of the adjacent angles so formed is 180 degree. Okay. Is that clear? Okay. If a ray stands on a line, the sum of the adjacent angles so formed is 180 degree. Okay. That means what? If suppose if this is A, B, C, D, right? So here, if you can see that CD is a ray, stands on the line AB, right? So here, CD, ray CD stands on a line AB, right? There is a line AB and CD stands on it. Okay. And this ray actually makes two angles, right? Therefore, two angles are formed, angle ACD and angle BCD are formed, right? Then, according to this theorem, the sum of these two angles, the two adjacent angles, is 180 degree, right? Means angle, sum of angle ACD and BCD, right? This is equal to 180 degree. So if there is a straight line and any ray stand on it, then it forms two angles, right, which are the adjacent pair of angles, then their sum has to be 180 degree. Is that clear? Right? Theorem 2. The sum of linear pair of angles is 180 degree. Or you can say, other way to say this, when the sum of two adjacent angles, when the sum of two adjacent angles is 180 degree, then they are called as linear pair of angles, right? Okay. So when the adjacent angles are said to be linear pair of angles, same which we have discussed here in this part, linear pair of angles. So when adjacent angles are said to be linear pair of angles, when the two non-common arms are opposite rays, that means their sum is 180 degree, right? That means the adjacent pair of angles whose sum is 180 degree, then those adjacent pair of angles are called linear pair of angles, right? So it is important to know that in linear pair of angle, the opposite arms also always form a straight line, right? If they are not a straight line, they are not forming the straight line, that adjacent pair of angle is not a linear pair of angles. Are you getting that? Yes, ma'am. Sama and Anvi. Is that clear? Now look at this example. There are two figures here. Figure A and figure B. Right? Can you tell me which one of them are adjacent pair of angles? Sama. Which are adjacent pair of angles? Which one of them? Figure A shows adjacent pair or not? Figure B shows adjacent pair or not? Tell me. So figure A and figure B both shows adjacent pair of angles. Both are adjacent, right? Because both are following the condition of adjacent pair of angle. They have a common vertex. This is the common vertex. This is the common vertex, right? Okay. Their one arm is common. This is common. This is common here, right? And their non-common arms are on the either side of the common arm, right? So these two arms are on the either side, right? Similarly, these two arms are on the either side of OC, right? So both the figures, right? Both the pair of angles are actually satisfying those conditions, and both are adjacent pair of angles, right? This is also adjacent pair. Okay. This is also adjacent pair. Right? Now, Anvi, which one of them is linear pair of angles? Or either both of them are linear pair? Tell me.
Yeah.
Right? So if you can see here, for figure A, right, what is the sum of the angles? 30 degree plus 60 degree, 90 degree, right? Here, what is the sum of the angle? Adjacent pair of angle, 55 degree and 125 degree, and this is 180 degree, right? Okay, both are adjacent, but figure B shows linear pair of angles, right? So here, this adjacent pair is also called linear pair. Why? Because their sum is 180 degree, right? So such adjacent pair of angle whose sum is 180 degree, right? ये भी adjacent pair है, but इनका sum 180 नहीं है, right? So this is not linear pair, right? So linear pair of angle are the adjacent pair of angle whose sum is 180 degree. Are you getting that? Right? So for figure B, this is a linear pair of angles. Right? Is that clear? This is not a linear pair. Why? Because sum is not 180 degree. Right? Is that clear? What is the difference between adjacent pair and linear pair of angles? Is that clear? Now, there are some other results based on the theorems, right? Okay. So you can say that corollary 1, write down. Corollary 1. Corollary means these are the results based on the theorems we have studied, right? Corollary 1. Now, what corollary 1 says? That the sum of all the angles formed on the same side of a line at a given point on the line is 180 degree. Right? So what is the corollary? The sum of all the angles formed on the same side of a line at a given point on the line is 180 degrees. What does it mean? Let me draw this first. Suppose this is a line, right? And there are certain angles formed on the one side of the line, okay, at a point. Suppose this is a point where the angles are forming. 1, 2, 3. Right? All the angles are formed at the same point. Yes or no? And that common point is O. Right? Okay. And on the one side only. On the one side of the line AB. Right? Okay. So OE. This is line OD. This is line OC. Are you getting that? So according to this corollary, the sum of all these angles formed on the same side. Same side means sari isi side. Can you see that? एक ही side में सारे, right? And they are actually at a one point, at a common point on the line, right? Then their sum is always be equal to 180 degree, right? That means sum of this, suppose this angle 1, angle 2, angle 3, angle 4, right? So what will be the sum of these angles? Angle 1 plus angle 2 plus angle 3 plus angle 4. This will be equal to 180 degree, right? So their sum will always be equal to 180 degree. Is that clear? Okay, so this is the result or the corollary from the theorems which we have studied on linear pair of angles, right? Okay. So sum of all the angles formed on the same side of a line at a given point on the line is always 180. Is that clear, Samanandi? So basically, if you want to prove this, right? So you can see that suppose you can take any ray, right? Suppose you are taking this ray OC, right? And it stands on the line AB, right? And we have a theorem, right? What is the theorem? If a ray stands on the line, then the sum of the adjacent angles so formed is 180 degree, right? Okay, that means sum of angle AOC, this and this total is 180 degree. Hearing that? Okay, and angle 1, 2, 3 are the parts of angle COB only, right? So then can we say that angle 1 plus angle 2 plus angle 3 plus angle 4 is 180 degree? Are you getting that? Okay, so in this way we can prove this. Now, corollary 2. Corollary 2, what it says? Again, another result that the sum of all angles around a point, sum of all the angles around a point is 360 degree. So sum of all the angles around a point is 360 degree. What does it mean? Suppose we have a point and we have so many angles around that point. This is a ray. Another ray from the same point. Another ray from the same point, one more ray, right? Okay. So you can see that from this common vertex O, right? There are 4 angles which are formed around the point. Then what will be the sum of these angles? That is 360 degree, right? So if this is suppose angle 1, angle 2, angle 3, and angle 4, right? Okay. So according to this corollary, angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to 360 degrees. So these are the angles around the point O, right? So whatever angles you are forming around this point, whether they are 4 or 10 or 30 or 50, their sum is always equal to 360 degrees. Is that clear? Are you getting it? Okay. Now, how can you prove this? How can we prove this?
A complete circle is 360 degrees.
Yeah, but how you will prove this? There should be some proof, right? Suppose we have a ray, right? We are drawing a ray here. Okay. And this ray is O. I'll just give the names to all the rays. Suppose this is OA, B, this is OC, OD, and this which we have formed is OE, right? We have produced this ray, and this ray is in the backward direction to the point. Okay, means it is in the backward direction of OB. Getting it? Okay. So EOB is a straight line. EOB is forming a straight line. Yes or no? Okay. So let's see what is the proof of this. OE ray is drawn opposite to ray OB, right? Okay. Are you getting that? Okay. And OA, that means EOB is a straight line when we have produced. Therefore, EOB is a straight line. Right? And now look at this ray, OA. If EOB is a straight line, then OA is a ray stands on a straight line. Right? And we have a theorem on this, right? So we can say that OA stands on line EOB, right? Therefore, what we can say that angle AOE plus angle AOB is equal to 180 degree, right? Okay, so if an ray stands on a straight line, the two adjacent angles which are formed, their sum is 180 degree, right? So angle AOE and angle AOB, right? You can say 1 and just you can say this angle is suppose 1, 2, 3, 4, yeah, AOB and AOE, right? Okay, so this is equal to 180 degree, right? Now, as we know that sum of all the angles at a point on a given line on the same side is 180 degree, right? Okay, so that's why we can say that angle BOC means these three angles, this, and this, right? They are on the same side of the straight line EOB, right? Okay, so their sum has to be 180 degree, right? So angle BOC plus angle COD plus angle DOE, this is equal to 180 degree, right? Why? Because the sum of all angles at a point on a given line on the same side of it is 180 degree, right? That's why their sum is 180 degree. Getting it? So this is suppose your equation number 1 and this is your equation number 2, right? Now add them, adding 1 and 2. What you will get? Angle AOE plus AOB plus angle BOC plus angle COD plus angle DOE. This is equal to 180 plus 180. That is 360 degree. Okay. Getting that? Okay. Now angle AOE and DOE. AOE and DOE. Angle AOE and DOE. This and this. Right? This is DOA. Getting that? Right? And that's why we can say that angle AOB plus BOC plus COD. Angle COD plus AOD. Right? Sum of these two angles. This is 360. Right? And hence we have proved this that angle 1, 2, 3, 4 is 360 degree. Is that clear? So in this way we can prove that sum of all the angles around a point is 360 degree. Is that clear? Sama, Anvi.